Is China taking over the economy of the world? Their unveiling of a never-seen space station has left everyone, especially the Western world, in questionable states. This video will be revealing the re-innovation of one of China's most impressive achievements in the tech world. What does this mean for China's economic revolution and the future of space travel? To enjoy more stories like this, don't forget to subscribe to us and click on the notification bell to be the first to see what we have in store every week. Tiangong, the Sky Palace, is a permanently crewed space station constructed by China and operated by China Manned Space Agency in the low Earth orbit between 340 and 450 kilometers, or 210 and 280 miles above the surface. The construction of the station is based on the experience gained from its prototypes, Tiangong 1 and Tiangong 2, as well as the purchase of aerospace technology from Russia in the early 1990s. The purpose and mission of Tiangong is to provide opportunities for space-based experiments and a platform for building capacity for scientific and technological innovation. The structure of Tiangong is that of a third-generation modular space station, as Mir and the International Space Station ISS, but with more cool features than others. They assembled in orbit from pieces launched separately, unlike the first-generation space stations Salyut, Almaz, and Skylab, which were not designed for resupply, and the second-generation modular space stations, such as Salyut 6 and 7, and Tiangong 1 and 2 stations that are designed for mid-mission resupply. The third-generation space stations are designed to greatly improve reliability, reduce costs, shorten development cycles, and meet diversified task requirements. Tianzhu, the heavenly vessel, with a mass around 13,000 kilograms and a payload of around 6,000 kilograms, is used as a robotic cargo spacecraft to resupply this station. Tianzhu is a modified derivative of the Tiangong 1 spacecraft. The first module of Tiangong is the Tianyi, Harmony of the Heavens, core cabin module CCM with a length of 16.6 meters, 54 feet, a diameter of 4.2 meters, 14 feet, and a mass of 22,500 kilograms, or 49,600 pounds. It is in charge of providing guidance, navigation, and orientation control for the station. It is made up of 3 sections: the living quarters, a service station, and a docking hub. The living quarters are the life support systems for 3 crew members. They contain a kitchen and toilet, fire control equipment, atmospheric processing and control equipment, computers, scientific apparatus, communications equipment to send and receive communications via ground control in Beijing, and a bunch of other equipment. The module also provides the station's power and propulsion. The second module, but the first laboratory cabin modules, or LCM, is the Wentian, Quest for the Heavens. Wentian has a length of 17.9 meters, 59 feet, a diameter of 4.2 meters, 14 feet, and a mass of 23,200 kilograms, or 51,100 pounds. It provides backup functions for the CCM by providing additional avionics, propulsion, and life support systems. It has 3 extra living quarters for a short-term stay that can be used during crew rotation. Aside from being a backup system, the Wentian has an independent airlock cabin which replaced the Tianyi's docking hub by serving as the main entry-exit point for extravehicular activities, or EVAs. It is equipped for various types of experiments with multiple interlaced science racks and 22 payload adapters on the exterior. The EVA can be used for future spacewalking and has a 5-meter-long robotic arm. Just as the Wentian, Mentigon, Dreaming of the Heavens, was the second laboratory cabin module, but the last module. It has an expanded in-orbit experiment capacity which carries 13 experimental racks and 37 external payload adapters. The Mengtian is designed with multiple sections which include pressurized crew working sections, the unpressurized cargo section, the cargo airlock/on-orbit release mechanism which conveys payloads from inside the station to the outside, as well as the control module section featuring external experiment adapters, a communication antenna, and 2 solar arrays. Both Wentian and Mengtian provide a pressurized environment for conducting free-fall or microactivity experiments, which could only be conducted for a few minutes on Earth. Experiments can also be placed on the outside of the modules for exposure to the space environment, cosmic rays, vacuum, and solar winds. Generally, Wentian is equipped majorly for life science, while the Mengtian focuses on microgravity experiments. The laboratory cabin module's axial port is fitted for docking at the axial port of the core cabin module, which rendezvous equipment. A mechanical arm called the indexing robotic arm moves Wentian LCM to the starboard side, and the Mengtian LCM module to a port side of the CCM. The indexing robot arms reassemble the LiPo arm used in Mir externally, but it is a lot more different internally. The indexing robot arms are used when docking is needed in the same plane, while the Lipia arm controls the pitch of the spacecraft to redock it at a different plane. The chin arm on the Tianyi module can be used as a backup for docking relocation. The Tiangong space station is provided with real-time communications, including live video and video links, but the Tianlian 2 series of data relay satellites, which is a constellation of 3 satellites launched into geostationary orbits. It is powered by the electricity provided by 2 steerable solar power arrays on both Wentian and Mengtian. These arrays use gallium arsenide photovoltaic cells that convert sunlight into electricity, which are designed to last up to 15 years. Energy is also stored in the system to power the station when the Earth casts its shadow on the space station. As a third-generation space station, resupply spacecraft replenishes fuel from the station's propulsion engines for station keeping, to counter the effects of atmospheric drag. To adjust the main station's orbit, Tiangong is fitted with conventional chemical propulsion and ion thrusters mounted on the ball of the Tianyi core module. To improve the technology, China is working on developing the Hall effect thrusters, which will use magnetic fields and specifically designed ceramic shields to repel damaging particles and prevent corrosion. During the testing phase of the ion drive of the thrusters ran continuously for 8,240 hours and as such indicated its sustainability for the station's designated 15-year lifespan. The ion thrusters are the world's first Hall thrusters to be used on a human-related mission. The Tiangong station features 5 robotic arms, with the longest chin arm being 10 meters long, mounted on the Tianyi core module. The Wentian module has a similar 5 meter or 16-foot long robotic arm that is 5 times more accurate in positioning than the chin arm. The Wentian arm is basically used to transfer extravehicular experiments and other hardware outside the station during EVAs. The Mengtian's robotic arm can retrieve experiments from the cargo airlock and install them onto the external adapters fitted on the module exterior. It is also used to launch microsatellites. Though they are of the 3rd generation, but unlike the US orbital segment of the ISS where there was spacewalking to manually interconnect cables, piping, and structural elements, the Tiangong modules are self-contained and pre-assembled, with the assembly method related to the Soviet-Russian Mir space station and the Russian orbital segment of the International Space Station. This places China as the 2nd nation to develop and use automatic rendezvous and docking for module space station construction after Russia. Before we move on to how Tiangong was assembled, let me take a quick pause. Hit that subscribe to our YouTube channel. As far as assembling is concerned, the official construction of the Chinese 11 mission space station began in April of 2021. The planned missions are 3 module launches, 4 crew missions, and 4 autonomous cargo flights. On 29 April 2021, the first component of the station, Tianyi core module, was launched into orbit aboard the Long March 5B rocket from Wenchang spacecraft launch site. A month later, Tianzhu 2 anonymous cargo spacecraft in preparation for the Shenzhou 12 crew that will test the Tianyi were launched to the Tianyi core module. These Shenzhou 12 teams docked with the space station on 17th of June 2021, the first visitors for the Tiangong station. They stayed for a period of 3 months, examining the core module, verifying the key technologies, and installing various devices like a thermal controlling system and a panoramic camera outside of the station, after which they were undocked from Tianyi on the 16th of September 2021. After the first crew returned in preparation for the arrival of Shenzhou 13 crew on the space station, Tianzhu 3 anonymous freighter was launched from the Wenchang satellite launch on the 20th of September 2021. The Shenzhou 13 docked with the space station on the 15th of October 2021. They stayed for 6 months doing orbit experiments, spacewalks, and studying for the station's future expansion. The crew stayed 182 days in low Earth orbit and returned to China after much testing on the 16th of April of 2022. 1 month after the return, China launched Tianzhu 4 cargo spacecraft in preparation for the next crewed mission. The automated freighter docked with the space station on May 9th, 2022 and carried vital maintenance equipment and a refrigerator for scientific experiments. China officially started the final construction phase for the space station on the 5th of June 2022 with the Shenzhou 14. 3 astronauts were to oversee the arrival of 2 laboratory modules, Wentian and Mengtian. They installed carbon dioxide reduction systems, tested Fentian spacesuits, and debugged Tianyi core module. Tianzhu 3 was undocked from the station on the 19th of July 2022 in order to make way for the arrival of the Wentian module on the 24th of July in 2022, which was launched and rendezvoused with the Tianyi core on the same day. The Wentian module featured backup avionics, propulsion, and life support systems, improving Tiangong space station's operational redundancy. The third and final module, Mengtian, was launched on the 31st of October in 2022 from the Wenchang Space Center and was assembled with the station 13 hours later. On the 10th of November, Tianzhu 4 cargo spacecraft unlocked from the Tiangong. Tianzhu 5 launched 2 days later. The Tianzhu 5 carried supplies, experiments, microsatellites, and gifts for China's first crew handover ceremony in orbit to the space station. The completed station had extra capacity for expanded crew activities and living space for 6, allowing crew rotation. The Shenzhou 15 crew and Shenzhou 14 crew spent 1 week together after they were launched on the 29th of November for handover and to verify if 6-man operation is sustainable. The Tiangong space station is made suitable for life and designed with home automatic functions and appliances that are controlled with remotes. This is achievable because of all the items in the station are marked with QR codes. As a result of this, the crew can identify, locate, and organize items using their tablet computers, thereby keeping everything in order. To ensure healthy eating, the space station has an equipped small kitchen table and a refrigerator, a water dispenser, and the first ever microwave oven in space flight. For easy communication, the astronauts wear a bone-conducted headphone and microphone. The station's core module, T&E, provides the living quarters containing of 3 separate sleeping berths for the crew members. It has a space toilet, shower facility, and gym equipment. Additionally, living quarters for short stay are located in the Wentian laboratory module. Although China had wanted to build its own space station, but they're increased after US Congress prohibited any Chinese participation in the international space race in 2011. Chinese Tiangong is the result of the signed cooperative agreement between China's National Space Administration and the Italian Space Agency in November of 2011. It also involved cooperation from France, Sweden, and Russia. The China Manned Space Agency (CMSA) supports the proposal regarding foreign astronauts' participation in Tiangong Space Station. Just like the ISS, the Tiangong Space Station can also be seen with the naked eye from Earth due to sunlight illumination reflecting off the module and solar panels, reaching a brightness magnitude of at least -2.2 mag. Following the design of Tiangong, the station is expected to expand from 3 to 6 modules, with the Tianyi, Wentian, and Mengtian modules having improved versions. At first, a multifunctional module with 6 docking ports will be launched. Also, the expanded version would have 3D printers, robots, improved robotic arms, and space debris observation, detection, and warning systems. And that's all for today, folks. Don't forget to hit that like button on your screen to see more of our videos. And be sure to subscribe to our channel for more content like this.